Hello and welcome to our STEAM project number 8, based on the Raspberry Pi Pico and MicroPython. These lessons are designed for the somewhat experienced STEAM teacher. We call this intermediate level the Sherpa level. In this lesson we are going to build a portable weather station using the DHT11 temperature and humidity sensor, and we will show the readings on an LCD display. My name is Peter, I am the founder of Educomondo and a certified STEM instructor and course developer. The goal of today is to integrate the DHT11, which is the digital humidity and temperature sensor, integrate the 16:2 LCD and how to include a library for this sensor, learn how to make this project independent from your laptop, in other words, make it run from within the Pico, and make sure that your class works as a team and optimizes their solution skills. Because we have detailed in previous Arduino lessons the working of the DHT11 and the I2C LCD, we are not going to repeat this. You can always go back to lesson number 20 of the microcontroller competency series to refresh your class's memory. Actually, we will build the same project as in that lesson number 20, so it will be a great teaching and learning moment to experience the differences between the Arduino and the Raspberry. Let's take a closer look at what we need for this project. The large breadboard with the Pico installed and the pinout reference card. The DHT11. The LCD 16:2 display, the box of preformed wires and a bundle of jumper cables, including the male-female DuPont cable. And as you can see, I have tiered off 4 cables so that we are not hampered by a bunch of cables that we are not using. And of course, the little cloud to cover the DHT11. Show your students how you have built the project so that they will be able to reproduce this on their own. It is not that difficult and they should be able to do this. So take a look at the completed project. The DHT11 has 3 pins. The ground pin goes to one of the ground pins on the Pico. The middle pin is the volt pin, and that one goes to the 5-volt Pico pin VSYS. The signal pin goes to GP15. The LCD is the I2C model, so we only have 4 pins to worry about. The 5-volt pin goes to the Pico V-bus, and the ground to one of the ground pins of the Pico. The data pin is connected to GB6 and the clock pin is connected to GPIO7. And as cherry on the cake, we put the small cloud over the DHT11. Give your students a couple of minutes to build this on their breadboards. Once they have all finished, they are ready for the programming part. We connect the Pico to the laptop and open Thonny to create a new file. We call this file Mobile Weather Station. The programming is not as straightforward as one should think. With the Arduino, we had ready-to-use libraries in the IDE for easy installation. With MicroPython, there are libraries modules and drivers, but sometimes you have to search hard and it can be a bit of a hassle to install them. So to make the LCD work, we have to look for a library. There are a number of libraries on GitHub, but for this lesson, we use the library that we took from www.toptechboy.com. Click on the source code and look for the copy symbol at the top of this section. Click on copy, paste the core into Thonny, and then save it to your Raspberry Pi Pico. It must be saved with the file name lcd1602.py. It is important to copy this library on the Pico because we will need it to work as a standalone project. Depending whether or not you have internet access in your classroom for your students, you may want to prepare this up front and copy this library to all Picos. Now that we are back in our Thonny environment, let's start coding. So our file is called Portable Weather Station in our comments, and since we have not written the library ourselves that we are using, it is only polite to thank the people or organizations that helped you. So here we can type a comment doing that. So code based on the work of Top Tech Boy and Sunfounder. Thank you! Exclamation mark. Now that we have done this, we are ready to import our classes and our modules. So from machine, we import pin. From LCD 1602, we import LCD. From time, we import sleep. Okay, and this time we are lucky because MicroPython does include a library for the DHT11. So from DHT import DHT11. Good. First, we need to define the variable pin for the DHT11 signal, and we have linked that to the GPIO 15. So signal pin equals 15. And we need to define that this is an output pin. And we also need to trigger the internal pull-down resistor to ensure clean readings from that sensor. Now I know it is a bit strange that we need a pinout, but that's just the way the library works. I have also tried to use pull-up, and although the results remained the same, the program crashed after a couple of readings. DHT11 pin equals pin, and in between the rounded brackets signal pin. It's a pin out and it's a pin dot pull down. Okay. Now we need to define an object, and we call it sensor, from the DHT11. So sensor equals DHT11, and in between brackets we mentioned the pin, so DHT11 pin. We will also introduce here a way to check the working of the Pico by letting the onboard LED blink in the program. But first we need to create it. And we do that by typing let pin equals the pin, and this is pin number 25, and it is a pin dot out. Also, for the display, we need to create an object. LCD equals LCD, open and close the rounded brackets. Next, we get into our infinite loop, while true. And while true means an infinite loop, so whatever is coming is going to go on forever and ever. And we want the internal LED to blink, which can be done through a very simple code sequence. So let pin, and first we put it off, so we give it a value of 0. Then we sleep, or we put a delay in of ½ a second, followed by a 1, so it's going to go on, and followed again by a sleep of ½ a second. Now, why would we want to do this in the first place? Well, this is handy to check whether the Pico is at least running this code in case nothing appears on the display or the REPL. Next, we need to tell the DHT11, our object sensor, that it has to measure something. And very literally, we have to type sensor.measure. And what does it have to measure? It has to measure the temperature. So temperature in Celsius, and we call this temp C, equals sensor dot temperature, open and close rounded brackets. But it also has to measure the humidity. So humidity, hum equals to sensor dot humidity, open and close the brackets. Right. But we also want these values to appear in the REPL. And here we will do some nice formatting that is available in the Python language. So \R stands for override, and we end with an open quote. This will show the readings of the DHT on one line instead of printing the lines one under the other. So bear with me as I'm typing the command sequence. So print, open the brackets, R, It is also recommended to include 1 second as a delay to allow the sensor to make its measurements properly. This 1 second is, by the way, also indicated on the datasheet of this sensor, so it's always a good idea to consult the datasheet when in doubt. So sleep 1 second. Now we have to bring the readings to the liquid crystal display. Ask your students whether they still remember how to tell the LCD that the text has to start at the first position of the first line. Indeed, this is the position 0, so 0, 0, followed by some text. And in MicroPython, this is done by typing lcd.write 0, 0, and then we type a string, temperature in C, and this, I have to close the bracket here, this really resembles something that we saw in the Arduino, but to write a variable temperature C, we have to turn it into a string, and we do that by putting string in front of this variable. So lcd.write on the position 0, 1 this time, and we put str and our variable temp C. And here we add a delay, let's say of 2 seconds, just giving us the time to read the temperature on the display. To clear the display, so that no letters or any of these artifacts remain, we type lcd.clear. Okay. And we do the same for the humidity reading. So lcd.write on position 0, 0, humidity in percentage, lcd write in position 0, 1, the string that we make from the reading humidity, and again a sleep or a delay of 2 seconds. Okay, well, this has been some pretty heavy coding, so let's hope that all of this works. But it isn't finished yet, because we want to make this a portable weather station. And how are we going to do that? Well, Pico can run a program upon booting, and that program is called MainPy. Make sure that this program is in the same directory as the libraries, because otherwise it will not work. So in Thonny, we can go and save this program onto the Pico, and you may have to override an existing MainPy. So if we go here, and then we will override this one here and see whether it is working. The temperature is 19 degrees, dropping to 18 degrees. And let us see if it works also on our LCD. And yes, as you can see, it is giving us exactly the same readings. If you wish, you can invite your class to go outside and do some additional readings. If in some groups it doesn't work, tell them not to panic. Ask them to do some logical fault finding. Were there any error messages in the REPL of Thonny? Are the right Picos selected? Did you connect the components to the right GPIOs? Are there any loose wires or legs? Is the pot meter of the LCD correctly set? Or maybe they just got unlucky and they picked a broken sensor or display. That's it for lesson number 8. I hope you and your class enjoyed it. In lesson number 9, we are going to link an infrared receiver with a remote control transmitter and learn about hexadecimal numbers. Looking forward to welcoming you again, and bye-bye for now.